This week on BSD Now, Allan and I are in Tokyo for AsiaBSDCon, but not to worry, we have full episode lined up and ready to go. We got hackathon reports from OpenBSD, we got NetBSD reproducible builds, C programming tutorials, and more. Stay tuned for your place to be, SD. BSD Now, episode 184, Tokyo Dreaming, recorded March 8th, 2017. Hey, I'm your host, Chris Moore.
And I'm Allan G.
And we're glad to have you with us this week. So I lied on the date a little bit there. We're recording this early because, as the title suggests, me and Allan are actually over in Tokyo at the moment.
I think if you're watching this when it comes out, we'll probably be actually in the middle of the Dev Summit.
That's right. So. I think the 8th or 9th there.
Or depending on time, we might be asleep.
Yeah, it's going to be fun. I mean, we're going to have a great time.
Home,
Yeah, it's going to be a very good conference. And, of course, hopefully we'll get to run into a few of you out there as well. So come by and say hi. But, looking forward to giving you some post-conference wrap-up after we come back. So we need to get into your news and headlines first this week, though. So, of course, we got a lot of OpenBSD news. These guys did another hackathon here recently. It looks like A2K17, which we were just discussing beforehand. We believe is in Australia. But we have a whole bunch of reports here. So, Allan, why don't you start us with a Patrick Wilt's report on ARM64 work?
He said, I knew as soon as I stepped off the airplane, I was going to melt.
Oh, no. Okay.
In preparation for my impending death, I spent the whole week debugging and bringing up the OpenBSD ARM64 port on QEMU. He says, surprisingly, I actually survived the heat. But he says, when I arrived at the hackathon, he had a ARM64 image running in QEMU, and he somehow managed to work around 100 or so blobs to start the OpenBSD kernel on the Pine 64. Since QEMU is rather slow and we really prefer running on real hardware, no matter how much of a toy it is, I got to work on implementing the driver bits for the Pine 64. After an interesting debugging session with Theo, finding a few uninitialized variables, we finally had OpenBSD running on actual hardware. Now this allowed us to start working on a release build. And then to go into more detail about that and getting things working with LLVM and setting up the USB bus and so on. He says, all that said, it's been a team effort with Dale Rand did a lot of the heavy lifting for the 64 ARM bits and relying on a bit of preparation that I had done before, and then they managed to put it all together at the hackathon.
Oh, very nice. Yeah, that's cool to see. Okay, so next up we have on Anton Jacot talks to us about syspatch, RC.D improvements, and more. So let me go ahead and start from the top here. He says, for once, I did not try and plan anything for this hackathon because I wanted to take the time to think over a few things and talk with a few fellow developers. But then he goes on and says, first up he started to work on was syspatch, which is their upcoming binary patch tool. So they simplified some code. He said they're now running all network-related actions as well as crypto verification as a separate unprivileged user, just like our installer does. He said they had a lengthy discussion with Theo and others about what they wanted, how we wanted our tools to use a common place and to know where to fetch the operating system components. So they settled on having an Etsy install URL file. He said another topic that he kept working on was a small yet important RC.D improvement, which is being able to catch hanging daemons at startup. So be able to catch like the background or ampersand daemon failure and eventually get rid of the RCBG variable and other options, so there's less knobs altogether. He said he started working on this in Cambridge. He thinks it's now ready to be committed. He said while the diff ended up being relatively small, it does change how the RC.D start action works, and so he's waiting for the 6.2 release cycle to begin before putting it in. Let's see, he enhanced some AWS AMI creation scripts for OpenBSD installations. It now creates a 4 gig image with all the standard partitions. Let's see, the sizes are the minimal advised by the auto partition disk label. So there's no need to over-provision these cloud instances anymore. So yeah, that sounds like a productive week for sure.
Yep. And then Martin Pouchot worked on fixing some of the remaining issues with the netlock that they had introduced to try to split out more of the networking code under its own locks. He says it was not been an easy task, but made it. And he says we, because this wouldn't have been possible without the help of a bunch of other people, including Bloom and his awesome automated regression test setup, which they have a link to. And talked a bit more about that, and then also said since he had so many different machines available, he decided to start fuzzing the USB stack. The first problem he ran into is that his USB cable was dead, which explained why he didn't manage to make the fuzzer work last time he tried. After the first day of fuzzing common drivers like the USB hub, USB human interface device, and the keyboard, without finding any panics, I decided to look at the USB audio driver. It found so many panics in the horrible custom descriptor parsing that I ran away from USB for this hackathon. I then spent some time working on the libr thread. I chose an alternative mutex and condition variable implementation based on CAS and Futex. Once those were past the base regression tests, he started porting more tests. Thanks to these tests, he found an unfixable flaw in his condition variable code. So he started porting Musil, the other alternative C libraries implementation instead. And he says at the same time, he had a nice chat with TB at OpenBSD.org about creating a tool to generate dynamic graphs based on KDump output. This would help a lot when analyzing processes are doing over long periods of time. This led me back to the schedule code, where I found that for some workloads, CPUs are playing ping pong, process moving back and forth between cores. Interesting, we talked about that one a couple of weeks ago with NetBSD, working on trying to solve that problem. He says, when I finally implemented dynamic profiling for i386, just like you'd done for AMD 64 at the G2K16 hackathon, this combined with an ISC licensed CTF tools allows us to build a dynamic tracing framework. So they're working on their dtrace compatible but not CDDL licensed dtrace tools.
Okay. Very nice. Well, next up, we have Ken Westerback writes in about how his week went. He says, of course, he retreated from the heat into the hacker room. He cleaned out a collection of Control M's that were in his tree as a result of spending some time reading the warning messages generated during his system build. He said no actual bugs were found, but some surprising code was accidentally uncovered and exposed to the light of day. He said an enterprising attempt in Make to remove files using sudo if they resisted the first try that was forcibly removed by Theo. He said, I then trolled through most of the directories he had touched, remove a raft of superfluous white space, which will save the eyesight of future splunkers. Let's see. He said, by the time this was complete, the paperwork had been processed for allowing beer into the hacker room, and now actual serious coding could begin. That is usually about the time the real coding happens. Let's see. He said, the mission this time was move forward on a new experiment in improving the management of the system network configuration. The approach was defined in Cambridge in September, but I spent the intervening months trying to figure out how to write a proper OpenBSD daemon, about which I turned out to be wrong on every count until I went back and reread the old papers and new code. He said that being done, he then used this trip to poke and prod the network stack into accepting a new routing socket message called RTM proposal for the moment. He updated the route monitor so it could display the contents of this message. He hacked DH client so that it issued the new message when it wanted to configure its interface, which then he could see appearing in the route monitor. So he said he put up a big mission accomplished email, updated his tree to pull in the latest work of others were committing, booted a new kernel, and then started DDB, and it was staring at a DDB prompt at that point. So he said a quick trip to the next table. Claudio pointed out that the latest changes to the routing socket code meant I had to rework changes a bit. So he did that and then sent out an updated mission accomplishment email. So he said, unfortunately, I was not quick enough to save Florian from visiting the same DDB prompt. Whoops, sorry. So anyway, looks like there's working on some proposal to get the RTM proposal flag in there here in the near future as well. So we'll see how that lands.
Yeah. And then the last one, Bob Beck, worked on LibreSSL. He says, I went through LibreSSL and attacked all of the constant time functions in the BigNum library and changed these functions to use, as used internally, to always use the safe constant time mode of operation to somewhat mitigate the timing attacks. This is JSing and I bumped the LibreSSL major versions and started moving a lot of the bits out of the SSL/TLS structures into private locations, removing publicly accessible API that is not used or should not have been used unless you're a crack-addled rhesus monkey. Bob Beck for you. We are still dealing with ports fallout, ensuring that most ports still build, and we have had to move a few things back where we were maybe a little too aggressive with privatizing. But largely it's been a success and will let us move forward at unifying more of the libSSL code to make our lives easier going forward. So I think that's partly replicating some of what OpenSSL is planning to do with the next version, where a lot of those structures are becoming private with accessors and so on, to make it easier to have less breakage of the ABI when they're moving things around internally, and just to stop programs from poking things they're not supposed to.
Okay.
He says he also did a bunch of fixes to FTP, which is their FTP/HTTP downloader client, as well as the FTP CGIs that are used at OpenBSD.org to automatically pick mirrors. And now that their installer supports TLS in the installer, and other new awesomeness done by RPE at OpenBSD. He also wrote and committed OCSP check. So we have a command line tool to use to do the OCSP stapling on servers, replacing the need for a lot of nasty OpenSSL commands.
Sure. Yeah, that'll be a lot easier.
And they thank the people for organizing the Dev Summit and the University of Queensland for giving them the location to do it in.
Cool. Okay, so our next story here, NetBSD is not reproducible.
Sorry, I should say now.
What? Okay. Yeah, okay. I was going to say, that doesn't seem to mesh with the rest of the story. But anyway, for you, NetBSD is now reproducible. So tell us what Christos Zolas has been working on here. I guess he posted something on the blog.
So he posted up on the NetBSD Foundation blog saying that it is now possible to do NetBSD builds completely reproducibly for AMD 64 and SPARC 64. Nice. He says, I've been working on and off for this for almost a year, trying to get more reproducible builds. That meaning the exact same source tree will always build the exact same CD-ROM image, which is, that's very reproducible. That's not just individual binaries of the same, but we're going to get exactly the same CD image out of it. He says, I did not think at the time that it would be quite so much work or quite so difficult, so I did not keep a log of all of the changes I needed to make. I also... not the only one working on this. Many other NetBSD developers have made improvements over the past 6 years. I would like to acknowledge NetBSD's build system, also known as build.sh, which is a fully portable cross-build system. The point there is that you can actually build NetBSD on not NetBSD, which is something I know FreeBSD aspires to have that someday as well. This build system has given us a head start in the reproducible build work because they always bring all the tools they need themselves, so they don't have to worry that, if your system has a slightly different version of this tool or that tool, it's not going to work, because they've already worked around that problem. He says, I would also like to acknowledge the work done by the Debian folks who have provided a platform to run, test, and analyze reproducible builds, with a special mention to the Diffoscope tool, which can analyze binaries, and rather than just a diff, can actually understand a lot of the binary formats and tell you what's different or which container in the executable format the change is in. So you can diff two files instead of seeing that, these bytes and hex are different. It'll say it's actually, this is the timestamp or the signature from the tool or whatever that's different, and give you an idea of where to find that problem and go and fix it.
Sure.
So that, it says by finding out what the differences are, and if they are containers, what they contain, and then running the appropriate formatter and diff program actually makes it possible to tell what's different between the files. This is finally other developers who have started, motivated, or did a lot of work behind this include Jörg Sonnenberger and Thomas Klausener, and he thanks them for their work on reproducible builds, and Todd Verling and Luke Muburn for their work on build.sh. So then his post actually goes into the source of a lot of the non-reproducibility, including timestamps, things like tar or AR, which is an archiver for making .a files, or file systems and so on, all have timestamps. And if you build it at a different time, you're going to have this problem. And even in the case of making a CD image or a memstick image, you actually have the modified times of the files in the file system and so on. The way to handle this is different in each of these different programs, but the approach is to make them produce files with a 0 timestamp, or a specific timestamp that makes sense. And so it's just like every file ends up with the exact same timestamp, so that if you build it now or later, you end up with the same actual file. The other was to find and remove dates, times, authors, file paths, etc., from that are embedded in source files. Some programs like to report the date and time when they were built, the author who built them, the name of the host they were built on. That's one of the things you see in uname on FreeBSD, and even the loader tells you on which system it was built. This can be done either by programmatically finding and creating source files containing that information during build time, or by using standard macros like date and time. Usually putting a constant time or aligning the information altogether solves the problem.
I wonder what the time is they set it to when you do it.
Some of them is literally like 0, so January 1st, 1970. Some of them it's like if you were doing the reproducible release of FreeBSD 11.1, we'll just pick like the day we decide we're going to release it or whatever, and or maybe it'll be a couple days before that. But the day we decide to start the builds, just that day at midnight or whatever, and we just say every file modified at this time. And if you want to reproduce it, you just set this variable, and it forces all the files to have that same date and time.
Oh, that's cool.
But then, when you set the date and time, what do you have to consider after that? The time zone you're building it in.
Of course.
So certain file systems like ISO 9660, which is used to make CDs and DVDs, don't store raw timestamps, but formatted times. Actually restores it as a string, apparently, rather than as just the time. So to achieve this, they convert from a timestamp to a local time, which means that if you build in a different time zone, you're going to get different results. I think usually the thing for this is that all your build stuff happens in UTC, but same thing. Other thing is, turns out nowadays when we do build world and so on, we do it with the -J flag and use all of our CPUs instead of only one. But that means that directories can get and files can get built in a different order, even if you run it twice on the same computer. Because if it just took a little bit less time one time, and it just means, that thread's done, let me give you the next work, or maybe it wasn't, and it get to, so the order can be different. And so they have to deal with that in order to get files to actually come out the same. So the build order is not constant, especially in the presence of parallel builds. Neither is the directory scan order. If those are used to create output files, the output files need to be stored or sorted so that they become consistent. They also have non-sanitized data stored in files. Writing data structures into raw files can lead to problems because you can end up with, different computers, different amount of RAM. It can end up built differently, especially running these programs in different operating systems or with and without ASLR, or even just two different machines with different ASLR will end up in different random locations. Symbolic links and paths, having paths embedded into binaries, especially with debugging information, can lead to different binaries, especially when you end up with symbolic links and relative paths and so on. And then there's tools that have inconsistencies, like GCC. If you have the profiling hook enabled, it on different architectures, like say RISC, it utilizes the current function number to produce the labels, and the processing order of those functions is not guaranteed. So a second build, even on the same machine, might come up with different numbers. Or if you're making a USB stick and use the GPT partition type, that involves creating a globally unique, like a UUID, right? The whole point of GPT is it's a GUID, a globally unique identifier.
Sure.
Meaning that if you do it twice, you're going to get different numbers. And if you want the CD image to be the same, you're going to have to deal with that.
I don't know if I would care that much about the CD image being the same, as long as the individual binaries on the CD, or checksum right, I'd be cool. That's a lot of work.
The block allocation of MS-DOS type file systems is also random. So, good luck with that EFI partition. And then MakeFS, that you use to actually build the ISO image and so on, uses time zones with timestamps for ISO 9660, random list for block selection for MS-DOS, and stores stray pointers in the superblock in FFS. So it doesn't matter if you're using CDs, FAT32, or UFS, you can end up with some randomness in there. Also, your toolchain, right? Every program that is used to generate other outputs seems to have needs to have consistent results. In NetBSD, this is done with using build.sh, which builds a set of tools from known source before it uses those tools to build the rest of the system. But there are a large number of tools, and there are also internal issues within those tools that make their output non-reproducible, such as non-deterministic symbol creation or capturing part of the environment in the debugging information. So even that system can cause problems. And then you have build information tunables and the environment. Is if you happen to be building NetBSD and you have certain variables set, it will result in your stuff being different, and then it doesn't look reproducible. So they've created a whole set of variables that controlled by one master variable. So if you set the MK repro to yes, then it sets a whole bunch of environment variables that will try to force everything to be the same. And with that, hopefully you will get the same result in the end. So it says reproducible builds are controlled on NetBSD with the two variables mkrepro, which is set to yes, and then mkrepro timestamp, which is used to set the timestamp of the build artifacts. So you can set, say, the release day.
Okay, that's cool.
This is usually set as the number of seconds from the epoch. So you want C time in there. The build.sh minus capital P flag handles reproducible builds automatically. So all you have to do is build.sh with minus P, and you will get your predictable output. But it goes into more detail about how they actually handle the timestamps and deal with that, how they handle the order of files, how do they deal with the toolchain problems, all those various bits. And then they say, as of 2 days ago, we have, or I guess as of February 20th, which is 2 days ago today, it will be a couple of weeks ago by the time people see this, we have finally reproducible builds for AMD 64 and Spark 64, and they're working on a bunch of the other architectures. They say they want to also try varying more parameters in the build system. So one of the things the Debian tool provides is a big list of variables to set differently. Like things you wouldn't necessarily think of, like the time zone, but not just that, but locale information. Like, if we're building it in French, we use a comma as a decimal point and a decimal point as a comma. If you're formatting a number, it can be completely different. All kinds of weirdness can happen there. I saw one of those with ZFS on a Mac. Kilobytes is not just K, it's KB or something like that in the output. And it made ZFS replication copying properties not work correctly with the shell script I was using. I was like, silly Mac. Man. So I had to add some stuff to make ZFS output it raw without the, local formatting. They also want to verify that cross builds are reproducible. So if you're using your big AMD 64 machine to build something for RISC or your Raspberry Pi, you want to make sure that you can get the same Raspberry Pi SD card every time as well. Even if you're building with different non-Raspberry Pi computers to build your Raspberry Pi image. They also need to verify that this all works as an unprivileged user. If you're building as not root, does any of this break? And then they want to test it on all of the platforms, which when NetBSD says all, that's a big number. Sure.
Well, the Spark 64 users are really clamoring for their reproducible builds here, but that's cool. Yep. Okay, well, next up we have Features or Faults, the Redux from Ted Eubanks. Yeah. So tell us about what he's doing here. I guess he has a class at Notre Dame, or he gave a talk for a security class at Notre Dame.
Yeah, so he went to Notre Dame and gave a talk at a security class based on his older talk, Features are Faults, with some various commentary that he's added to it since he presented it originally. He said it was an exciting trip with an opportunity to meet and talk to the computer vision group as well, which was interesting. Some other highlights include an Indiana skillet that he had for breakfast, which came with pickles and was amazing. I don't really think of pickles as a breakfast food, but okay.
Okay. Some people, I go to Japan, eat weird breakfast food every time. So.
And he got to explain the wonders of CVS to a bunch of Linux users, or a Linux user group at lunch. Okay. And then he gave his little talk. So talks about a couple of different things, but he says he got started in OpenBSD back about the time when he started college. Although he had a slightly different perspective then, he was using OpenBSD because it included so many security features. Therefore, it must be the most secure system, right? For example,
Naturally.
at some point, I required a second computer. And what's the first thing anyone does when they get a second computer? That's right, they set up a Kerberos domain so they can have single sign-on.
That's what I did. How did he know?
I networked the two computers with a parallel cable. It was the first thing I did with two computers.
Oh, man.
I guess he kind of skipped over that and got to actually using the network for something. But
Sure.
he says the idea that more is better was everywhere. This is about around the time that IPsec was getting its final touches, and everyone knew that IPsec was going to be the most secure protocol ever because it had so many options and than any other secure transport. But he says he'll come back to that bit. He says there's been a partial attitude adjustment since then, with more people recognizing that layering complexity doesn't result in more security. It's not an additive process. Just because you have 8 different security systems doesn't mean that you're actually 8 times more secure. It can actually mean you have 8 times more chance of one of those failing and messing everything up on you. Yeah.
Sure.
So he says there's a whole talk here about the perfect security that people can't or won't use, but he's not going to have time to go into that. OpenBSD has definitely switched directions, including less code, not more. For example, all the Kerberos code was deleted a few years ago.
Yeah, that's true.
He says,
they keep doing that.
Let's assume that you have on average, there's one bug for every 100 lines of code. That's probably on the low end.
That's optimistic.
Now say your operating system has 100 million lines of code. If I've done my math correctly, that's literally a million bugs. So there's one reason to avoid adding features. But that's a solvable problem. If we pick the right language and the right compiler and the right tooling and have enough eyeballs and put in enough effort, we'll fix all the bugs. We know how to build mostly correct software. We just don't care. As we add features to software, this increases its complexity. New, unexpected behaviors start to emerge. What are the bounds? How many features can you add before craziness is inevitable? We can make some guesses, like say 1,000 for sure, probably less than 100, 10 maybe. But he actually argues that it's quite possibly that the answer is 2.
No. Okay.
Interesting. So his law that he's making up here is that if you have 2 features, you have bugs. But he's also saying that his corollary to that is that it's impossible to have a program that has exactly 2 features. Any program with 2 features has a third feature, but you don't know what it is.
The undocumented feature, right?
Or the strangeness that can happen if you put those 2 features together. So he says, my first example is a bug in the original NetBSD FTP client, which is what OpenBSD would have inherited when they forked from NetBSD. So, so they took the original NetBSD FTP client and they added one feature. Which had one feature and they added a second feature, and what they got was a third misfeature. So this is, our story begins a long time ago. The origin of this bug is probably older than I am. In the dark time before the web, FTP sites were used as a popular way to publish files. So you ran your little FTP client, connect to the remote site, and then you can browse the remote server somewhat like your local file system, using LS and so on. You can list files, change directories, and download files. Typically, there would be a README file telling you what's what and where to find stuff. But you didn't need to download a copy of that to keep and then go and read it. Instead, you could pipe the output into the program like less or more. This is right there in the FTP client. No need to disconnect. So he actually shows an example of that. CD cool files, ls, get readme, pipe more. No need to disconnect or anything. Yep. So fast forward a few decades, HTTP is the new protocol of choice. HTTP is a much less interactive protocol, but the FTP client has some handy features for batch downloading like progress bars, etc. So OpenBSD decides to add HTTP support to the FTP client. This works pretty well. Yeah. Lots of code is reused. However, HTTP has one quirk, however, that FTP just doesn't have: redirects. the server can redirect the client to a different file. So now you're thinking, what happens if I download http:// some file, and the server sends back 302, redirect you to http:// pipe reboot. FTP reconnects to the server, gets to 200, starts downloading, and saves it to a file called pipe reboot. Except, no, that's not what happens. The function that saves the file looks at the first character of the file name, sees it's a pipe, and runs that command instead. Now you've just rebooted your computer. Or worse.
Oh, ouch.
Whatever the bad guy told your computer to do.
Yeah.
He says, it's pretty obvious that this is not the desired behavior. But where exactly did things go wrong? Arguably, all the pieces were working according to the spec. In order to see the bug coming, you need to know how the save function worked, you need to know about redirects, and you need to have put the implications of those two things together. And so the post goes on into a bunch of other examples of things like this. It's always interesting to see, a lot of these are things that actually happened, which makes some really good case studies for some of this stuff. But I definitely don't have time to read it all today, but I recommend people check this out and read it. It's really good stuff. So he says, what do we do about this? He says, that's a tough question. It's much easier to poke fun at all the people who get things wrong, but the idea is to actually fix it.
Yeah, it's harder when you're the author, right? And you have to actually be on the hook for taking care of these.
Yeah. So it says, we can try to fix it. My attitude are shaped by my experience with the OpenBSD project. I think we're doing a decent job of containing the complexity. Keep paring away at dependencies and reducing interactions between the different parts. As a developer, saying no to all feature requests is actually very productive. It's much faster than actually implementing the features.
For sure.
Sometimes users complain, but I've often received later feedback saying, actually, it turns out that having it simple is quite useful as well. There was a question about which of these vulnerabilities were found by researchers versus which ones were caused by troublemakers. The answer is that most, if not all of them, were found by researchers, but it made me realize one additional point I hadn't mentioned. Unlike the prototypical buffer overflow vulnerability, exploiting features is more reliable. If you find a buffer overflow in a program, it takes very specific knowledge, and it can end up being different on different architectures. Whereas if you're exploiting a feature, that feature is likely to be the same on all the different architectures. Exploiting something like shell shock or image tragic requires no customized assembly code. It's independent of what type of CPU you're running on, of what OS you're running on. Doesn't matter if it's Linux or OpenBSD. The bug is in Bash. It doesn't matter what version of the OS, about stack alignment, different malloc implementations. None of that matters because you're not exploiting something low level. You're using a feature, and the program was designed to let you use the features.
Sure.
Within about 24 hours of the initial release of Shell Shock, I had logs of people trying to exploit it against my machines. So unless you're on about a 12-hour patch cycle, you're going to have a bad time.
That's rough. I wonder how many people did get backsplit by that, who just hadn't had time to patch.
It really comes down to, it turns out features are worse than bugs.
Right. We just need to stop all features at this point. Spend 10 years securing everything.
Yep.
Then we'll slowly introduce them, right?
Yep. Which brings us to our next point.
All right, there we go. So now some new features.
No, this one is actually re-implementing the ZFS-CTL interface, which is what controls the .ZFS directory. So if you don't know, when you're using ZFS, hidden in the root of each file system is a hidden .ZFS directory. It won't show up no matter how many flags you give ls, but if you cd into it, it's there. And it has a subdirectory called snapshots, and there's a virtual directory for each snapshot, and you can go in there and access versions of your files without having to manually mount the snapshot and copy files around and so on. It's very handy for just looking around inside your snapshots and so on. It says the current code is written on top of GFS, which is a library with a generic support for, basically it's a generic VFS library, making it easier to port code from Illumos to other operating systems. But because of the significant differences between Illumos VFS and FreeBSD's VFS model, both the GFS and ZFS CTL code were heavily modified to work on FreeBSD. Nonetheless, they still contain quite a few ugly hacks and bugs. So Andrew Gapon re-implemented it in the FreeBSD native ZFS or VFS specific bits. So he says this is a re-implementation of the .ZFS code with all the VFS specific bits rewritten from scratch specifically for FreeBSD, and only the bits where it actually interacts with ZFS were reused from the original code.
Oh, interesting.
So then he gets a bunch of implementation details about how it works. And he says some of those ideas for how he ended up doing it were actually picked from independent work on the same kind of project done by Will Andrews when he was at SpectraLogic. So the big change that happened here is a feature was removed that I didn't know existed.
Yeah, I was going to say, when I read that, I was like, oh, I could have done that the whole time? I didn't know.
Yeah. So on a Lumos, in that ZFS directory under snapshots, you can create a new snapshot by doing mkdir, the name of the snapshot, and it will create a snapshot. That worked on FreeBSD until it was removed yesterday. What never worked on FreeBSD were the other bits of it, where on a Lumos, you can also delete a snapshot by removing the directory, and you can rename a snapshot by just renaming the directory. Yeah, I didn't know those were a thing.
No, and you wrote a book on this kind of stuff,
exactly. So I'm still finding features in ZFS I didn't know about.
Totally messed that one. Yeah, I never even would have thought to try that.
Yeah.
Like, just never occurred to me, like, even to attempt.
It's a very nice, elegant, simple interface, but at the same time, the code for it is horribly complex, and that's why rename and remove were never done on FreeBSD, and so it didn't really make sense to keep the create snapshots that way, and also, it was a bunch of work to re-implement it, and it seems like a feature most people didn't know existed, so they're not going to miss it. But it might be interesting in the future to actually see all three of those re-implemented. In particular, when I was talking to a bunch of people about it on IRC, while it would be a lot of work and the ZFS command line tools work very well, Will Andrews actually pointed out that it could be handy to be able to create snapshots over NFS by just going into that directory and doing mkdir or whatever. And then that led me to think, well, yeah, I wonder if that would work with Samba as well. So I know you can expose the snapshots to Windows via the volume shadow copy feature so that you can browse the snapshots and restore individual files. I don't know if that can create snapshots. And, if creating a directory there could allow it to, that could be interesting. But at the same time, I don't think it does, and, it's probably not worth all the extra effort. We could put that effort into other things, but... if people could come up with some really good use cases for it, it might be pretty interesting.
It would be interesting to see it supported, but yeah, I don't know. I mean, I lived without this long, so it's not going to change anything in my life, but aside from just the intellectual curiosity to know that was a thing now. Well, hopefully we'll see somebody take that on in the future. If that's a feature you want, start nagging people or write a patch. That would work too. Okay, so before we get to our interview this week with Conrad, we got our first sponsor, which is going to be the IX Systems, of course, and the website for that, ixsystems.com/BSDNow, where you want to go ahead and fill out that little form and put in your contact info so you can get in touch with their sales engineers. And what's really cool about talking to the IX sales engineers is they know their stuff. So you can talk shop with these guys. You're running a database? Great. Tell them what kind of record size you're using, what kind of database, how is it set up, what kind of traffic do you do? Doing websites? Tell them about that. Heck, you're doing storage? Okay, NFS, Samba, what file sizes, how many files, how deep nested are directories. I mean, give them all that info because they can help turn that into designing the optimal server that's going to do the best in your particular use case and provide a minimum level of performance that you expect. So what's really cool about IX is, of course, they can get you the latest and greatest Intel processors, custom design things. They have everything from little FreeNAS minis that are cute and quiet and sit under your desk, all the way up to powerhouse systems with how many NICs did that one system have?
24 10 gigabit NICs.
Yeah. So, I mean, they've done some really crazy work in the past. So, of course, get in touch with them and they will help design the next system for whatever project you have, big or small. And when you do, make sure you tell them you heard about it here on BSD Now, because they love to hear from our listeners. And it also puts you in a little different class of a customer as well, letting them know, like, oh, these people know their stuff and they can talk some technology with you and figure out exactly what's going to perform the best in your situation. Okay, we're joined today by Conrad, and I'm going to apologize. I can't pronounce your last name, so I'm not going to butcher it live on here. But Conrad, who's a FreeBSD developer who is here to talk to us about encrypted kernel crash dumps, which is really cool. So first of all, thanks for being on the show with us this week, Conrad. We appreciate it.
Yeah, hi, Allan. Hi, Kris. Thanks for the invitation.
Oh, you're welcome. You're welcome. So since this is your first time on the show, we got to ask you the getting started question we ask everybody. So how did you first get introduced to BSD? What was your journey that brought you there?
I think I first heard about FreeBSD because that's the only BSD system I'm familiar with. By my brother. My brother showed me FreeBSD 5.4 when I was around 14, 15, I think. And I quite liked it, but it took me 2 years to convince myself to use it myself on my desktop. So in 2008, I installed FreeBSD 7, and since then I'm using it as my desktop.
Oh, very cool. Do you follow along with the DRM work and XOR drivers and all that then, since you're a desktop user?
I didn't use it like for with advanced features, let's say, at the beginning, but now it's since I'm a FreeBSD developer, everything's changed. So now it's
Sure.
I'm following the changes now.
Okay.
Cool. So what was the first code you ever wrote? Like, how did you get into programming?
I think it was a calculator written in C or C++. And I also got a book from my brother, which was Introduction to C, C++. And it was written by some Polish guy. But I quite liked it. It also took me a while to practice C, to write something more than just calculator. But it was fun back then.
Okay, so of course the big question we got to ask you about is encrypted kernel crash dumps. Like, that's kind of a big thing to go into. I guess before we ask you a little bit about that, what other things did you work on in FreeBSD first? Was there anything else that led you into working on encrypted crash dumps?
For FreeBSD itself, I didn't contribute before encrypted kernel crash dumps. Before I started with encrypted kernel crash dumps, I wrote some code for myself, like kernel modules during studies, because we had operating systems courses. I remember there was one module which did something basic, like detective nmap tries to scan your operating system because it uses some techniques to detect that. But encrypted kernel crash dumps was the first big deal, let's say.
Okay. So what exactly prompted you or made you interested in wanting to do kernel crash dumps?
So as a FreeBSD user, I wanted to contribute to FreeBSD, but I didn't have an idea what to do. So it wasn't mostly about the feature itself, but I wanted to do something interesting. So I heard about Google Summer of Code in 2013, and hopefully FreeBSD had ideas page where you can find something for yourself. And there was encrypted kernel crash dumps on a list. I studied cryptography and security, so it seemed like a good choice, and I tried to do that, so I was happy about it.
So what was your experience like working with Google Summer of Code?
First I talked to Trash, Edward Tomasz Napierała, about my ideas. I found it very nice that FreeBSD developers answer to many questions from GSOC students about their ideas. And I gave him some ideas, and he said that encrypted kernel algorithms is okay. So I posted my proposal, got another comment from FreeBSD developers, very helpful, and got accepted somehow. I was mentored by Gleb Kurtza, and the original design of encrypted kernel algorithms was far different from the final one. We wanted to use paths for it, a private encrypted file system, but finally decided not to do that, to make it simpler and I believe useful for more people. And GSOC was very, very nice. And thanks to GSOC, I met other FreeBSD developers. I went to EuroBSDCon in 2013, where I met Pavel, so I could continue my work with him after Google Summer of Code.
Okay.
So can you tell us a bit about how the encrypted kernel crash dumps actually work, like what the process is?
Yeah, sure. So the idea about encrypted kernel crash dumps is we want to protect what was in memory at the time a kernel panicked. And there are two groups of people that we want to protect it from. One is an attacker who maybe has an physical access to a dump device and could extract a password from kernel crash dump. And the other group is we've got operators who manage machines in a company, but they don't necessarily shouldn't have access to a crash dump. And to do that, we use RSA to encrypt a key, which is used to encrypt a crash dump. And so you have to have RSA keys. You have to generate them. You place the public key on a machine where you want to encrypt crash dumps, and you place a private key in a safe place where you will want to decrypt it and analyze. And cool. Use Dampon to actually configure it. There are two ways. You can do it automatically or manually. To do this automatically, during startup, you can use dump pubkey RCCon variable, where you set public key path, or you manually run Dampon with a K flag to pass a path to a public RSA key. Dampon generates one-time ASCII. By one time, it's used only during between two dump device setups. It generates it, encrypts the public key using the public key, and sends it to kernel. Kernel receives it, generates initialization vector, creates key schedule, and uses it to encrypt the crash dump. And here's one trick. Each time a kernel panics, we replace IV by SHA-256 hash of the previous value of IV, because it's possible to create multiple crash dumps between two dump device setups. You can do this by entering DDB using system control, which is called, debug kdb enter. You call do a dump function to write a crash dump, type continue to resume the systems, safeguard, and then repeat these steps. And given that we don't want to use the same IVs for two crash dumps, so we replace IV with a hash of it. And after system reboots, because there was a panic, you still have to encrypt it after you save it using safeguard. Safeguard looks at kernel dump header, and if there is written that there is a key in a crash dump, then it creates another file called key, which includes encrypted key. And after safeguard saves data, you can send it to another machine, the key and VM core file, and then use a decrypt core utility to decrypt the core. And decrypt core reads the key file and VM core file, and using capability mode, decrypts data.
Right, so it's writing the key that the crash dump was encrypted with the RSA public key into a file, and then on the other side, use the RSA private key to decrypt the actual key to decrypt the crash dump.
Yes, that's correct.
Interesting. Yeah.
We cannot store the AS key in plain text, because if someone has physical access to dump device, it could decrypt the core.
That's a good way to deal with
useless.
You need asymmetric keys in this case, because you're not trusting the machine that the crash dump's actually being created on.
Sure.
Yeah. And we don't have asymmetric crypto in kernel, so we need to encrypt it in userland. The AS key we have to encrypt in userland.
And it's you said it's all capsicumized as well?
Yes, Dampon and decrypt core use capsicum to do operations.
Does SafeCore use it?
Decrypt core and Dampon. SafeCore is not capsicumized yet, but it's my next goal, which should happen in the next weeks.
Nice, coming soon.
Cool.
So it sounds like a lot of moving parts here. So what was maybe the most challenging part of the project? Where did you spend the bulk of the time?
So as I was a student into 2013, kernel was a magical box for me, and I needed to study how things are working in kernel. But the most challenging was to understand how GM works and how to make encrypted kernel crash dumps to make them working on all architectures.
Mm-hmm.
I think these two things were the most challenging.
So it works across all the architectures?
Yes, we support full dumps and mini dumps. Mm-hmm. The part with full dumps was easy because we have one part in kernel, generic part in kernel, which is used to create crash dumps. Mini dump part was a bit harder because I had to modify all machine-dependent code, which is responsible for creating mini dumps. And we don't support text dumps because we use CBC mode for encryption. And in case of text dumps, we don't know the size of a text dump at the time a kernel dump header is created. Mm-hmm. So when a text dump is being written, kernel needs to jump to the beginning to update kernel dump header with its size.
Right, and usually with a text dump, there wouldn't be that much sensitive data anyway, right?
Sure.
Yeah. A user administrator decides what's to be included in text dump, so it's not that important to encrypt it.
So are there any plans to maybe integrate this with something like Colin Percival's panic collector? I forget what it's called now. But say the FreeBSD security officer or somebody could have a key, and I'd be willing to send my kernel crash dumps to them, but not to anybody else, kind of thing, to be able to actually aggregate these crash dumps and maybe find out what common crashes can happen.
So you mean like there would be one key to encrypt all crash dumps?
Possibly, like just
maybe it's like a service, right?
Obviously, the user would choose to do this, not have it automatic or whatever. But if somebody
it would be a cool idea, but then we would need to support like multiple encryption keys or chains of keys.
Possible.
Because I believe
I suppose you want to be able to read your
there
own
would be a need to. Yeah, but I never heard about such idea, but I think it's worth to think about it.
Yeah, I was inspired to ask that about Colin's work in particular, like if there was some way to tie that together, or people can turn that on and then submit the crash dump automatically to Colin or the security engineer, and hopefully let them look at it.
I think Colin says panic mail doesn't quite get a statistically significant amount of panics to be able to find many things. But I think part of that is because the way Colin structured it, it gets the text dump and then emails it to you, and then you have to manually decide to forward it to Colin and decide. And whereas I think people feel much safer if it was encrypted in such a way that they knew that only them and the person that is going to get the copy would be able to get it. So I think it might be interesting to have, the ability to encrypt that private key or the symmetric key to, say, 2 different RSA keys.
Yeah.
Cool. Okay. Well, let's see here. So what sort of things do you maybe need some additional testing or community input on? So are you asking people to try stuff out?
Yeah. Before I committed the changes, there was call for testing. Unfortunately, there was not big feedback to it. What we would need to do with encrypted kernel crash dumps is to test it on hardware for architectures which have mini dumps, in particular ARM64, MIPS, Spark. I tested it using QEMU, not in all cases.
Sure.
So it would be nice to have feedback. How does it work on these architectures?
Okay.
Did you ever test it with crash dumping to a ZFS ZVol?
I think crash dumps with ZVols don't work because it would have to go through GEOM, which is not available at the time of the crash dump.
Okay.
I thought we had a
deny now.
Well, I know there's a feature flag for crash dumps to ZVols, but I think that's only on Illuma, so I might have to look into that.
Okay.
I add that to my to-do list for the storage summit, actually.
So,
right.
And it's we were considering using GEOM for that, but it's necessary to write to a dump device directly.
Yeah, it makes sense. You're in the middle of crashing. The crash could have actually been in GEOM, so you can't really be depending on GEOM.
Yeah. You need a clean path to the disk or to the file. You got the next question, Allan?
So have you worked on anything else in FreeBSD? Are there things we can blame you for?
Yeah, there was an unsuccessful try to implement memory deduplication in compression in 2015. And that was also a part of my Google Summer of Code project. Unfortunately, I didn't implement it as I expected because VM subsystem seemed way too complicated to me, and it's still on my list to do it in the future. Last year, we had Google Summer of Code student who worked on conversion between Linux audit trails and BSM format. It's still happening. We already have the conversion, but it still needs some polishing. And we would like to change audit DSD to make it able to talk to Linux machines to distribute these files. So these two things are on the list. And capsicumizing safeguard, as I said before.
That would be good too.
So is that what you're going to work on next, or do you already have things you've started on since doing the encrypted crash dumps?
Safeguard is currently happening, and Mateusz, the student from last year, is still actively working on the feature. So this is what will happen in the next weeks.
Do you have any other big plans for what you'd want to do in the future?
The part with memory deduplication is very important to me, and I need to spend more time to understand how the VM subsystem actually works to do that.
Well, FreeBSD could definitely use more VM subsystem experts, so I'm all for you becoming one of those.
Yeah, that's a tricky area.
Yes.
Very cool.
So how do you keep motivated to work on open source stuff? I'm sure you're busy with your day job, although that involves open source as well, right?
Yeah. The only project I actually contribute to open source is FreeBSD, except some small changes. So in FreeBSD, there are two very nice things about how the community works. We have dev summits where you can talk to people about your problems to find ideas how to solve your problems. And you've got mailing lists where you can ask questions and get feedback from people who actually implemented some feature. And I think it's very important to have such technical support from people who create a project. And it makes open source very special, especially in sense of FreeBSD.
Very cool. Do you have any other hobbies outside open source?
I tried not to forget what I studied about. So I enjoy reading like books about theoretical computer science. So yeah, that's like the main hobby I've got on my spare time.
Okay, cool. Was there anything else you wanted to talk to us about?
Not necessarily, but I think it's, as I many times mentioned, Google Summer of Code. We're approaching the time when the next Google Summer of Code edition is happening. I hope FreeBSD will be selected also this year. So it would be nice to see more students getting involved in FreeBSD, and I'm really looking forward to proposals from them.
Yes, and I'm looking forward to more of them like you, and actually even Thomas or Traz before you becoming developers in FreeBSD after going through the Summer of Code.
Yeah, and at the time when I was Google Summer of Code, I wasn't like thinking about gaining source commit bit, but it is possible, and well, we're definitely missing people involved in FreeBSD, like students involved in FreeBSD who would like to continue their work after Google Summer of Code itself. So I'm really looking forward to work with these people.
Cool. Okay, well, great. Well, hey, thank you for being on the show with us today, Conrad. We really appreciate it.
Yeah, thanks.
You're welcome. And of course, we'll hopefully some folks out in the audience will try out your encrypted crash dumps and get you some more feedback, especially on those alternate like MIPS and ARM platforms.
Yeah, thanks. And if anyone needs help with configuring it or debugging, I'm ready to help.
Great. His email is def@freebsd.org, by the way. So there you go. Now you know how to get a hold of him. So again, thanks for being on today, Conrad. We appreciate it.
Thank you. Yeah, thank you.
Okay, time to head into the news roundup. But really quick before we do that, we got our second sponsor this week, actually, DigitalOcean. So website for that, digitalocean.com. You'll want to go there and create an account. After you've created the account, though, there's an option in the account settings where you can apply a coupon code. And that's where you'll want to put in the code FreeBSDNow. All one word, and don't forget it's FreeBSDNow, not BSDNow. And that harkens back to the early days, a couple of years ago, where they added FreeBSD support initially. And
why they originally came on the show was to tell us, hey, we have FreeBSD now.
Which is really cool. And since then, they've done a lot of cool stuff. So now they've got FreeBSD with ZFS. You can get 11.0.
You can get separate block storage that's not part of the VM. So you can have up to 16 terabytes of storage in case the 30 gigs of SSD they include in the $10 droplet isn't enough for you. Can also, they have load balancers now, so you can split the load across multiple droplets. So you can use a bunch of cheap ones instead of a more expensive one, and say only start up additional ones when your site's busy, and then save money when they're not, because you can also rent hourly.
which is really cool. In addition, they have a great console that lets you do weird things like maybe installing OpenBSD or Dragonfly or Net. I mean, really, you can do whatever you want here. You have full access to everything.
FreeBSD or Linux that the Droplet comes with, and then just overwrite it with your operating system of choice and do the install if you want NetBSD, OpenBSD, Dragonfly, whatever. And yeah, with the $10 credit, you just got to verify your account, and then you're good to go. And you can, at 1.5 cents an hour, you can go quite a while off a $10 credit and your little initial deposit.
Which is pretty cool. And, of course, locations all over the world. So pick a data center close to you, pick something far away.
San Francisco, Toronto, New York, London, Amsterdam, I think Frankfurt, Germany, and then Bangalore and Singapore for Asia.
Okay. Yep. Very cool. So again, check them out today. And of course, they have some fantastic tutorials on their website, great APIs, which will help make it easy to programmatically spin up and, of course, tear down VMs.
I need to spin up 36 droplets because there's a big live stream event. It's just click, click, boop, done.
Done. Yeah, it's really cool. So check it out today. Hopefully you'll enjoy them as much as Allan and myself have. Okay, so first up in the news roundup, we have some PBK DF2 performance improvements on FreeBSD. So that's always a mouthful. So encryption, I assume, here. So it looks like Joe Pixton's been doing some research.
So this is basically the key derivation function, which basically you give it a password, it does a bunch of work, and makes a much stronger key out of it that you can always recreate from that password instead of having to, you end up with a 512-bit key instead of your, 15-character password. But you don't have to try to remember that 512-bit key. You just remember your password, type it in, let it work for a little while, and it comes up with that key. So that PBKDF2 is used in Geli for disk encryption. And in order to decide how many iterations of that function, so basically you can tune the PBKDF2 with the number of iterations to be faster or slower, because you want the password to be hard for somebody to guess, but not take forever to generate when you want to decrypt your Geli volume. So what Geli does is keep doubling the number of iterations until how long it's going to take is about 2 seconds. Right? So if it does it and it doesn't take it long enough, it just doubles the number until it takes about 2 seconds. Turns out that because of the way the spec for PBKDF2 was written, almost every implementation is actually done suboptimally.
Oh, okay.
So basically there's two, an inner and an outer round of a SHA-512. And it turns out that most of the time people were deriving the beginning of the outer part each time inside the loop. Whereas you can actually do that just once outside and then just calculate the second half of it. So you do the first half of it, save it, and then for each of the, in this case, on FreeBSD, the defaults on most machines is about 1 million. Instead of doing the beginning part 1 million times, you do it once, save it, and then for each of the 1 million times aside, you copy the started one, and then finish it, get the result, use it, and then the next time you just copy that original unmodified started one again for each time of the million, so you're actually doing a lot less work. So it turns out it's twice as fast to do it that way. But the way the spec spells it out, it doesn't hint you towards doing it that way. So yeah, Joe Pixton did some research and presented it at the Password 15 conference and found that almost all the implementations are twice as slow as they should be. Where this becomes a problem is the fact that an attacker could use the optimized version of this algorithm, and so they could guess the password twice as fast as you think they can. So now in FreeBSD's
you're only half as strong as you thought you were.
So for FreeBSD and Geli, it's not a big deal because even half of 2 seconds is 1 second, and if they have to guess, a billion times a billion possible combinations, 1 second each is going to take a really long time. But until a change we talked about a couple of months ago, on OpenBSD, the number of iterations was only 8,000 or 8192. So that being cut in half could make a really big difference.
Sure.
And so since then, OpenBSD has switched away from a SHA-1 based HMAC with 8,000 iterations to using bcrypt as its key derivation function and using a benchmark very similar to the way on FreeBSD to get about 2 seconds worth. Anyway, so if you're using Geli on FreeBSD, your data is not at risk at all. It's just we've improved this so that we're doing it the more optimal way. So if you have an already encrypted disk, what this means is it will take half as long to import now. So it'll be faster. If you create a new Geli thing from scratch right now, it will basically be twice as strong, taking the same amount of time because the algorithm is twice as fast. Sure. So if you have an existing one and you just want to be paranoid, you can use the Geli set key command to basically re-encrypt your master key with a new password, and it will do the benchmark and come up with twice as many iterations, and your data will be safer with twice as many rounds of the key derivation function. Also, if you don't like the benchmark, using the -i flag when you create the Geli originally or with set key, you can just specify the number of rounds you want. So if you like it being faster and decide you want the number that'll take about half a second instead of 2 seconds, you can specify that. Or you can be like, I want it to take 5 seconds every time. Then you can do that as well.
Sure. That's kind of cool.
So yeah, this
nice that it lets you be as paranoid as you want to be.
But yeah, so Joe wrote the original patch and submitted it to FreeBSD. And then John Mark Gurney took that, added some test cases to it, and got it all ready to commit, but then ran out of time, and I think he changed day jobs and never got around to committing it. In the meantime, I had made a bunch of changes in order to put the Geli stuff into the bootloader, and it made the patch not apply anymore. So I cleaned it up and got it reviewed and signed off by Pavel as the maintainer of Geli and Geom, and by the FreeBSD security team. And so this fix has been committed now.
Very nice. Very nice.
Yep.
Okay. Well, next up here, we have a quick how-to, updating screenshots in the TrueOS handbook. So doc writers, it might be time to pay attention. This week, we actually have a little bit of a good walkthrough on adding and update new screenshots to TrueOS's Sphinx documentation. For those who have not looked in the past, TrueOS and FreeNAS both have really fantastic documentations by the team over at IX Systems, and they use Sphinx as their doc engine. Often we get questions from users, though, asking, what can we do to help? But then they don't necessarily have programming skills that they can apply in all situations. So the good news is that using something like Sphinx is actually relatively easily, and after you learn a little bit of minimal RST syntax, you can easily help fix or contribute new sections even of docs to TrueOS or FreeNAS, for example. But in this particular blog post, Tim takes us through the process of replacing an old out-of-date screenshot in the handbook with, of course, the latest hotness. It shows an example of starting with a PNG file, locating the old screenshot name, and then adding an updated version of it. So Lumina-E becomes Lumina-F. And once the file's in the tree, then the relevant section of the REST code can be adjusted, and Sphinx build is run to verify that the output HTML looks correct. So, of course, what's really cool about this is using this method, you can easily get involved with documentation, and the next thing you know, you'll be writing bootloaders like Allan. So it's a win-win for everybody. So if you're looking for a way to get involved to get started, this docs is definitely one of those things. Everybody uses it. Everybody needs it at some point or another. So if you have a little bit of time to contribute, a little bit of syntax learning, you'll be in good shape and able to help docs. Sphinx is used all over the place. It's not just TrueOS and FreeNAS, though. So if you master it here, it's a very useful skill, and you'll find lots of places where you can apply that.
Yeah, sadly, it's not quite that easy, but the FreeBSD handbook could use updated screenshots as well.
That's true. See, you'll do Sphinx, then you get into the handbook. And then with our next story, of course, now that you've easily mastered all your documentation skills, you're ready to take on a new challenge. Come on, that bootloader is not going to write itself. So we want to point out some excellent resources to get you started on your journey into writing C. Now, before you think, oh no, more books to purchase, wait, there's some good news. These are actually the top 9 open source books that you can download in digital form free of charge. It's like, now I bet I got your attention. So, of course, we start the rundown here. We have a blog post over at ossblog.org, which is really good. But they start the rundown with the C book by Mike Banahan, Declan Brady, and Mark Doran, which lays the groundwork with the introduction into the C language and, of course, introductory concepts, more advanced concepts, etc. Next up, though, if you're going to do anything, you should do it with style. So take a look and read through the C elements of style, which will make you popular at all the parties. And no, we can't vouch for that statement.
Yeah. There's a FreeBSD style guide too. You could read that.
Right? You could read that as well.
Although that one's more examples. So I think you need to read the book and then once you understand the concepts, apply the FreeBSD style guide to your code.
Sure. From here, though, we have a book on using C to build your own minimal Lisp interpreter, which that sounds like a really cool project. There's a reference guides on GNU-C, some other excellent introduction and mastery books to help round out your programming skill set. So, of course, once you have all these, safely tucked away in the old brain box, your C adventure awaits. Hopefully, these books can not only teach you good C, but also make you feel confident when you're looking at bits of maybe FreeBSD world or kernel or any of the BSDs for that matter, Linux even, and you'll have a proper foundation to back it up. And hey, you managed to do that all for free. Just go ahead and grab that on your tablet or whatever e-reader device you use and start reading away. Definitely is some good knowledge to be gained there.
Kind of how I got started. My first real interest in C was modifying the source code of a IRC server to just change some of the messages that it spat out. And then, I started looking at trying to add features and stuff. And I did some terrible things in C.
Well, we all have to do that, and hopefully these books help guide you on the right path, though, so you make less of those terrible mistakes.
Yes. Actually, understanding what the pointers are and what they do helps a lot when you're reading other people's code.
For sure. All right, so next up we have running a Linux VM on OpenBSD. So over the last few years, we've actually talked a lot about virtualization. Of course, Beehive has gotten a lot of attention. We've talked about OpenBSD's VMM, but QEMU has actually not gotten mentioned very much here. So today we have a blog post with details on how you can deploy QEMU to run Linux on top of an OpenBSD host system. So this example starts off by showing us how to first provision the storage for QEMU, which, of course, there's a handy QEMU-image command. And this example is only going to have you create a 4 gigabyte disk, but maybe you want to go a little bigger for some more real-world usage here. Yeah. And then the next up is, of course, the QEMU command you're going to run to start the VM. So pay particular attention to the flags for networking and memory setup. Of course, if you want more than 256 megs of RAM, now is the time to make that change. But networking is actually always the fun part, as the author describes what his intended setup was for this. He says, I wanted OpenBSD and Debian to be able to attain an IP address via DHCP on their wired interface, and I don't want external networking required for the for NFS share to the VM. To accomplish this, I needed 2 interfaces since DH client will erase any other IPv4 addresses already assigned. We can't assign addresses directly to the bridge, but we can configure a virtual Ethernet device and add it. So doing the setup involves has a little bit of touching a few different files, but it isn't actually all that painful. Some of the you need some PF rules to enable NAT for the DHCP setup to assign a fixed IP address to the VM, and you're going to have some additional details on how to configure networking from inside the Debian VM as well. So for example, there's DHCP setup, which makes sure if you have the right MAC address, it always gives it the same IP address every time. Yeah, pretty painless stuff. You should be able to cut and paste most of the examples here. But once those steps are completed, you should be able to boot up into your VM and then mount NFS from the host and share data to and from the host to the VM pretty painlessly and still have a route out with NAT. So pretty good guide here, and I think should make it easy to deploy. So if QEMU is something you want to experiment with, or you're looking for another way to run virtualization on OpenBSD, give this a try. I mean, I'm sure you can apply 90% of this to running any other VM and just swap out the specific Debian network configuration for whatever the guest is you're using in this case. Okay, we're going to hit the beastie bits and feedback and questions here in just a moment. But before we do, our last sponsor this week, which is going to be Tarsnap. Website for that, tarsnap.com/BSDNow, where you want to go and get signed up and start doing backups right away. So what makes Tarsnap different from, we'll say, all the other dozens or hundreds or thousands of backup providers out there? It seems like there's a new one every week at this point. What's really cool about Tarsnap is a couple things. So first of all, everything's fully encrypted before it leaves your box. So you have control of your encryption key. Nobody else does. And because it's encrypted on your end, that means the data on the remote side is pretty much worthless to anybody else. For example, on the cloud side, if there's ever a security break-in or drives get lost or misplaced or rogue employees, you don't have to worry about that kind of stuff because all your data is encrypted over there. They don't have access to your key. It's just a bunch of gibberish. That's very important.
Yes, and we've seen with other cloud providers that, may have dropped a box or something. Sometimes when you delete files, they don't actually delete the files.
very
and then
subtle.
like a year later, the file's not deleted. It's like, well, that's how the cloud works. There's not really a way to get around that. But if you encrypt it with your personal key and then destroy that key, no one can ever get that file back, no matter what.
That's right.
That's the only way it's ever going to work. So that's why this is the way Tarsnap does it.
So another thing that's very unique about Tarsnap, because some people claim to have encrypted backups, but how many of them actually give you access to the source code to the client, which does all the encrypted backups? Well, Tarsnap does. So you can take it, you can audit it, you can have your team audit it, whatever you need to do to verify that you trust it, and you can even compile it yourself so you know you're running the right binaries. Like some, people may claim this is the source code, but who knows what's in that compiled binary, right? But I mean, if you're that paranoid, you can go ahead and compile it yourself and do your backups entirely from stuff you built with your own sweaty two little hands. So it's definitely good stuff. And I know me and Allan use it here. A lot of big companies and customers trust Tarsnap with their data because it's one of the only ones that can even make that kind of claim and then stand behind it.
In particular, I'm very happy that my credit card processor for my business uses Tarsnap.
Mm-hmm. That gives you some confidence. Like, okay, they must have somebody over there who knows what they're doing. That's really good. So definitely you should join that crowd as well and start using Tarsnap today. And, of course, if you ever talk to Colin or anybody over there on the Tarsnap side, tell them you heard about it here on BSD Now. Okay, so Beastie Bits time. So first up, we have a Mac Observer article, interview with open source developer and former Apple manager Jordan Hubbard. So you want to tell us about that one, Allan? Is there anything you wanted to?
45 minutes to listen to it yet.
That's pretty long. But anyway, it just goes, it sounds like here he goes through some time, a little bit of background on his time at Apple, and I guess
early BSD origins and
early BSD origins. So if you're a big Mac OS fan, you may want to take a listen to this very historical tour to the history of Apple.
It's just generic fun stuff like Jordan talking about childhood memories of being 8 years old and electronics geek going to Radio Shack and so on. So just lots of good stuff in there.
Okay. Very cool. And then next up, we have 2016's Google Summer of Code Mentor Summit and MeetBSD Trip Report from Gavin Atkinson over on the FreeBSD Foundation website.
Yeah, so Gavin has helped lead the FreeBSD project's Google Summer of Code stuff for a couple of years. So he gets invited to the Mentor Summit that they have in California. And he managed to work it so that he could go to the Mentor Summit and stay through for the FreeBSD Vendor Summit and MeetBSD. So this is actually a 3-in-1 trip report.
Nice.
He talks a bit about the Mentor Summit and getting to talk to organizers, people organizing Google Summer of Code for other projects, students that have done it, that kind of thing. Also talking about Google Code In, which is basically a hackathon. It gets people together for a couple of days and try to actually build a prototype of something. Talking about just open source stuff in general. Lots of discussion taking place, including how to attract more students, how to attract students from underrepresented countries and minorities and so on, how to get more people into GSOC, how to get ideas for GSOC, how to improve the Google Summer program itself. So what Google can do differently to make GSOC better. And then Google also covered what their thoughts are and how they want to change GSOC going forward and making sure that mentors are going to be okay with that. He says, overall, it was a very useful meeting, and being able to contribute our experiences to GSOC in the process will hopefully prove to be beneficial for both FreeBSD and GSOC in the long run. Then he got to attend the FreeBSD Developer and Vendor Summit, which preceded MeetBSD. And, he says there it's very useful to get to talk to people, the downstream consumers of BSD, whether those are mostly users or people that are building products and appliances based on FreeBSD, and understand what their issues are and how those can be fixed. And the other important thing there is also just getting to have FaceTime with other developers. So he said, once they moved into MeetBSD, there's very interesting talks about FreeBSD. There was talk about Beehive, and Kylie Lang from the FreeBSD Foundation presented about her work at Microsoft, getting Hyper-V and FreeBSD going together. Some guy named Chris Moore talked about something called TrueOS. Have you ever heard of that? I've What's true OS?
Not at all.
And then Rod Grimes gave a talk about the early days in FreeBSD, which was very interesting. I liked that one myself. But then he said he also got to spend more time with FreeBSD developers, including getting to sit down with Adrian Chad for a while and talk about the 802.11 network stack and the work he's currently doing on several Wi-Fi drivers. So it's good to see Gavin, more people getting involved in Wi-Fi. And then finally, Gavin and I and a bunch of the other ClusterMin team finally got to spend a chance with the ClusterMin team and discuss several current and future issues, how to make sure we have a better disaster recovery plan for Bugzilla, because I don't know if people remember, but a couple of years ago there was an issue with the database getting messed up and the restore took about a day and a half, and we'd like to get that. So next time it only takes 15 minutes. He says, overall, the experience was very valuable for both himself and hopefully for FreeBSD. And he's very grateful that the FreeBSD Foundation could help him cover some of the costs of going from the UK to California for an extended trip through all of these FreeBSD-related events.
Very cool. Well, thanks for sharing that, Gavin. That sounds like you had a good time there. It was good to see you as well.
It's glad to see you as well.
Okay, so next up we have feedback and questions. We only got a couple this week because we're actually getting way ahead on our episodes and getting ready.
More email.
Yeah. So we need more email from you because we're getting ready for a California trip. Next week we got the FreeBSD Storage Summit, and then we leave right after that for Tokyo. So
I'm home. I get to sleep in my own bed for 3 nights.
Yeah, I get 5 nights. That's a little better for me, but still, it's gonna be a whirlwind next couple weeks. So, let's get started here. Though we have Joseph who writes back as a follow up to a question earlier about BGP and Vultr. He says, "Hi, Allan, Kris, and JT. Thank you for reading and responding to my last email about BGP and TCP signature kernel option in episode 175. This is a follow up. Vultr's BGP system requires TCP MD5. For most things, they offer good support and instruction for FreeBSD, but for BGP, they only provide instructions for Linux. Maybe if I get this working, I can write something up and submit it to them. They do community docs like DigitalOcean." He said, "I resorted to compiling a custom kernel, which you said isn't all that hard. The main trouble is that it complicates updating the system." He said, "At first I tried compiling it on one of my test machines, but with only 768 megs of RAM." Ow. Okay. Anyway, he says it died before the kernel finished compiling. Yeah, I could see that. He said, "Since I have a server at home with 32 gigabytes of RAM," okay, that's a little better. He said, "It ended up compiling there instead." Okay, very good. Good choice. He said, "I'm using Puppet to distribute the custom kernel files by dropping the files in a folder and having Puppet module copy them to Puppet to distribute the custom kernel files by blah, blah, blah." I read all that wrong. "Having Puppet module copy them to boot BGP_kernel." Okay. He said, "My Puppet master runs out of a jail on my home server." He said, "This isn't the best way to get the job done, but it was quick and easy to set up." He said, "To actually update the kernel, I have to copy the contents of boot BGP kernel to boot kernel." He said, "But this is fine. I don't want Puppet automatically updating my kernel."
That
sounds reasonable.
That could go bad.
Yes. He said, "Once I have a working kernel, I run into another problem, which is turning on bird 6, which is, of course, the IPv6 bird daemon." He said it would immediately kernel panic the VM. Oh, he said, "It turns out a bug got introduced which failed to initialize a data structure in IPv6 in sysinet TCP subbar.c," and he has a bug link here for Bugzilla. He said, "So far the fix is in current and in stable 11, but it's not in the release engineer 11.0 branch yet." He said, "Since I want to stick with the release engineering branch, I just copied the one-line fix to the file on the release engineering branch and wrote a script to handle doing the SVN update, copy the file in place, and then compiling it via a cron job." He said, "It checks the MD5 of the file so it can email if the copy in SVN gets updated, so I'll know how to check in the fix for SVN." He said, "I think I figured out why this option is turned off by default." Well, just as an aside, I would just git clone it, make my own branch, and apply that fix. And
hopefully,
anyway, that's
the
just me.
changes going into the IPsec branch, when it gets merged, will make the IPsec and the TCP MD5 signature kernel module, so you'll be able to just load them when you need them instead of having to compile a custom kernel. So hopefully that'll get better. And yes, sorry that if bird 6 is crashing on 11, it seems like we should have an errata notice for that one.
Yeah, that would make sense. But he said, "I think I figured out why it's turned off by default. It's dependent on IPsec, which was also off by default before FreeBSD 11 because it had such a performance penalty even if you didn't use it."
Now with the changes they've done for that and the AES GCM stuff, it's not as the performance penalty is so small that we've turned it on by default.
That's cool. Let's see. She said if 11.1 includes it in the generic kernel, I will be able to use FreeBSD update again. I think that's the idea here. He said, should I post to a particular mailing list, file a bug report, do both, or something else? Well, I think you already pointed us to the bug report for the Bird 6 issue.
Yeah, so that one.
And I think you said it's been turned on in head, Alan. Do we have to
Well, I don't
file a bug
know.
report?
So IPsec is on by default in 11, isn't it? Oh, no, maybe it's in head. Okay. So I don't think IPsec on by default. I don't know if that, I think it's enough of an ABI change it won't be possible to put it into 11.1.
Okay.
Although maybe. I don't know. For that one, you might file a new bug. For the TCP subr.c one, you might be able to just bring that to the attention of the release engineering team and ask them if it would be possible to get an errata notice so that the next FreeBSD update build will include that fix for your generic kernel, although that won't help you when the bug is only exposed with the custom kernel anyway, right?
Cool. Okay, he says, I really love FreeBSD and wish it was used more. He said, I'm currently looking for a new job in the Boston area and love to work with FreeBSD, but he can't find any sysadmin or DevOps jobs looking for FreeBSD people. They're all looking for Linux. He said, the few job postings that I found that list FreeBSD included just with Unix and Linux, and they don't actually run it. Well, that's a bummer. You need to fix those. But
part of the problem is it turns out that, one sysadmin can run 100 FreeBSD boxes, but if you have 100 Linux boxes, you need a whole team of Linux admins.
Right. That's true. So you hire a bunch more of them. So he says, thanks again for the awesome show and indulging my long emails with questions about obscure functionality. No, well, if you have the question, somebody else probably does too. So it's best that we cover
FreeBSD as a BGP writer is kind of a thing we would like to work. So we'd like to hear from people when it doesn't. And hopefully we can, by reading this out to people, we can get more people to create enough of a demand that we get these, sorted out in the release branches instead of people having to wait for the next version.
Okay. Very cool. Thanks for writing in, Joseph. Yeah. So next up we have from Texas. Let's see. What did you say the person's name was? Ryan. Okay. So Ryan says, greetings from Texas. I have essentially listened to almost every show, although I don't know much personally about personally using the OS. He said, however, I love hearing about all the cool things that are going on in BSD. So my question is, do y'all have any recommendations for a good laptop with excellent out-of-box experience using TrueOS? And yeah, he wrote y'all, so I had to say it that way. No, I haven't lived in the South too long yet. So recommendations for a good laptop with excellent out-of-box experience. He says he also uses KDE with my Arch-based Linux distro and Windows 10 for gaming. He said he'd like to learn the multimedia capabilities for the OS and get a good feel for how it runs. Hopefully use FreeBSD as a media server, perhaps a router, or general desktop use. He says, thanks again for the great show. Nothing else like it, in my opinion. Well, thank you. So laptop-wise, the X1 Carbons I'm a huge fan of, and especially since they started working really well with TrueOS recently with suspend, resume, and accelerated video. Like, it's kind of a no-brainer. The Wi-Fi, sound, video, all that just works. I'd recommend those. I know, Alan, you have different Lenovo's as well.
Slightly older Lenovo's. I have. I keep finding Lenovo X220s on eBay for under $200. It's hard to turn that down. And then I love my T530. It's a bit heavier, but I do like it.
Still,
the X1 Carbon looks really nice. The advantage with something like the T530 or an X230 is that it's one generation older of the Intel wireless, which is just a little bit better, a little bit more mature. But the IWM is quite reliable now and not slow either.
I haven't had a crash in 4 or 5 months now since we track head. Yeah, those fixes went in 4 months ago, and it's just been solid ever since.
But yeah, now that you got suspend and resume on the X1 Carbon, I'm like, maybe I need an X1 Carbon.
It might be time. So I highly recommend the Gen 3 if you can get them still, and an NVMe integrated.
Yes.
Like, it's an actual NVMe device. It's not an NVMe hooked up to a SATA port. Like, it's fast.
It's exactly the same flash, but because you're not pretending to be a hard drive, you're actually able to do more than one operation at once. And so the exact same flash goes from being able to do 400 or 500 megabytes a second to 2 gigabytes a second.
Yeah, it's really sickeningly fast. Matter of fact, I'm doing more and more of my coding on there now, like pulling down huge, like the FreeBSD repo from Git or something. Like, it's like, oh, checked out, done. Like, it's really quick.
Although for the previous question about IPsec, Rikai double checked the source tree, and the IPsec option has been default on in FreeBSD head for 19 months. So it definitely, 11.0 includes IPsec by default.
Okay.
But the MD5 thing is not by default, so that's still not solving your problem yet. But hopefully that'll get worked around.
Okay. Well, Ryan, again, thanks for writing in. Hopefully you can use FreeBSD as a media server. FreeNAS is a great way to give that a try if you don't want to go through the setup yourself. But if you want to set it up yourself, it can definitely do that, do routing, do all kinds of stuff. So definitely enjoy and let us know how that goes. Okay, well, it's time to wrap up the show here, folks. Of course, me and Allan are still in Tokyo, enjoying ourselves. Please stop by and say hi. If you're out in Tokyo, we'll have fun getting to talk to you. It's always nice to meet listeners. And, of course, as we wrap up, we want to remind you to send questions, comments, show ideas, stories, topics. Basically, anything and everything needs to go to feedback@bsdnow.tv. That's the only place that gets monitored. That's the only place where we're going to be able to queue up your emails and get it into a future episode, which we've pretty much caught up on our backlog now since we kind of had to preload a bunch of episodes.
With the back-to-back travel. So, we're adding emails, and we need more.
So send more emails in, send questions, even if you think it's, silly or, oh, that's too easy. No. Ask the obvious ones because there's a lot of people who usually have the same question. So send it in, and, of course, we'll make sure it gets answered, and we'll look forward to speaking to you again soon.